A very common issue that we still constantly encounter is shown in Heap level 2 of exploit.exercises.com. This is a classic use after free vulnerability. Let's try to understand the code first. We have here a big while loop inside of main. In each round it prints the variable auth, which is a pointer to an object of this auth struct up here. And auth has the attributes name, which is a string up to 32 characters, and an integer. And the other variable that is printed is a char pointer service, which can point to a string in memory. So both of these are addresses, pointers. Then we read a line from standard input, maximum 128 bytes. So this is a secure fgets read, no buffer overflow. Afterwards, we have a couple of ifs that check if the input line is one of the following commands, either auth, reset, service, or login. Let's execute the program as well, and then let's talk about each command. When we first start the program, both the auth and the service pointer are null. Now we wait for input. Let's have a look at the auth command. When we type auth, it will allocate the size of auth, so that should be theoretically 32 byte for the name plus 4 byte for the integer. Then the whole allocated memory is overwritten with zeros. This makes sense because if on the heap data is constantly allocated and freed, then a newly allocated area can have old data in there. A free does not zero out the memory. So here it zeroes out on allocation. Afterwards, the length of the input line is checked so it doesn't exceed the 32 bytes available in the auth struct for the name. And if that is safe, the characters after the auth command are copied, the name of the auth object. Let's try that. Let's authenticate as admin. Cool. As you can see, the variable auth contains now an address. This is where the auth object is on the heap. Now the last command is login, which checks if the integer of the auth object is not 0. And if that's the case, we successfully logged in. Otherwise, if it's 0, then it tells us to enter a password. Though in this case there is not much more functionality than that, but just imagine that you are trying to log in as admin without knowing the password. So somehow our goal is to set the integer to a value and then we are authenticated. At the moment it seems impossible because the integer auth is never set anywhere, but we have learned from the beginning that there are bugs that allow us to modify variables. Another command here is reset, which will free the auth object on the heap. And this is actually where the issue is. You notice when we reset the login process, it frees the auth object, but as you can see, the auth variable is not reset to 0. It still contains the pointer into the heap where the object was before. And when we, for example, log in now, it will check the name attribute of that object. Well, it hasn't changed, so we are still unauthenticated. But the login command will use the variable auth after we just freed it. Use after free. Get it? Now the last command here is service, which will perform a strdup, a string duplication of the characters after the service command. So for example, we can specify that we want to use the hex service. And now we also have an address in the service variable. And strangely, it's the same one as auth. That is weird. So what does strdup do? Let's read the man page. strdup returns a pointer to a new string, which is a duplicate of the string s. The memory of the new string is obtained with malloc and can be freed with free. So it's just a convenient function that allocates the length of the string we pass to it and copies it there. So it will also call malloc and thus allocate stuff on the heap. And you can already guess why service got the same address as auth, because auth was freed. There was free space and service got the free space there. Let's look at this in GDB. First we set the assembler syntax to intel, and then we disassemble main. Let's first run it and use auth once, so we performed at least one malloc. Then press Ctrl C and check the address of the heap with infoproc mappings. Now we can print 20 words from the heap with examine. Also, because this application has still all the symbols and stuff inside of the binary, GDB also knows that auth is from the type strct, which we can print pretty again, and we can see here the string name and the auth integer. We can do the same for the service string. Now let's create a breakpoint before the printf, and with command we can then type what GDB commands shall be executed when we hit this breakpoint. We can use echo to print some strings to make it look more pretty, but first we want to print the heap. We echo a line, we want to print the auth variable, another line, and the service variable. At the end we continue automatically and finish the command sequence with end. Now let's rerun this binary. Okay, at first we get some memory errors because the heap doesn't exist yet. So let's allocate our first value by authenticating with auth as admin. Also, let's disable GDB's pagination so we always print everything and don't get the type return to continue dialog. Set pagination off. Now we can see here our heap. Like we expected, we have a chunk with our string name admin. But something is weird. Why is the length of the chunk only hex 10? That is only 8 bytes after you subtract the 8-byte chunk headers. Shouldn't it be like 32-byte name plus the integer? What's going on? Well, this is not that important for the solution, but this is what happens if you write shitty code and name everything auth. The struct is called auth, the struct auth pointer is called auth, the integer in here is called auth, and when the programmer calculated the size of auth, it calculates the size of the variable auth, not the struct auth. Thus it's only 4 byte, but malloc aligned it to 8 bytes. Gosh, people, please name your variables better. This is how bugs and security issues are created. Anyhow, let's ignore that for now. Earlier we are wondering how the free works, so let's free the auth object with reset and pay attention to what changes. Okay, lol, basically nothing changed, except that the first word of the chunk data got replaced with 0. That's because the first word in a free chunk is defined as the previous free chunk address, because free chunks are in a linked list. But we don't have another free chunk in the list, thus it's null. So really not much happened other than the malloc algorithm knows that the free heap starts again at the beginning and it doesn't care if there are still leftover values on the heap as long as the metadata, like the previous address pointer, are correct. Thus it only changed that particular value. Anyhow, we can now see that auth objects still exist with the pointer into the heap here. But the name is now empty with nulls, and the integer is still null. But let's use servers to allocate a string on the heap. Let's allocate just some recognizable characters like AAA. Note only 3 A's because the code is shitty and it also takes a space before the A's. Here in the heap we can see that the string got allocated, and we see that the name of the auth object has now some different values. Now let's allocate a new string with service BBBB and another one with CCC. We see the heap slowly filling up. And what's that? Suddenly the auth integer has a huge value. That's because it points into the heap where the CCC is stored. And if we now log in, then we get the message that we are already logged in. Awesome. I have to say, this level is so horribly broken. As I mentioned before, the code is so shitty that it allocates the wrong size for the auth object. The space is too small. I show you. Let's restart it and auth again as admin. Now simply enter a long service string and boom, we also overwrote the integer and we get the logged in message. So we didn't have to free the auth object with reset to solve it, but I wanted to introduce the term use after free, and that was also kind of the intended challenge.